Okay, today we're going to be looking at various types of player movement that you can implement in your own projects. So obviously there's always loads of different ways in which you can go about creating player movement. However, these are the primary three which I think you'll be probably using the most. And these three are a character controller movement controller, a transform-based movement controller, and a rigid body physics-based movement controller. Each one of these all come with their own pros and cons, but you can decide for yourself, and I'll kind of go over some of them myself as well. The first type of movement we're going to be looking at is the character controller movement. Some of the pros of using the character controller is that it has built-in collision handling and slope step support. It doesn't really have too much rigid body physics interference. It's quite predictable and easy to implement smooth, controlled movement. Some of the cons are mainly to do with physics. For example, you can't really do pushing or pulling against the character controller unless you create a little workaround, and also you don't get gravity by default and you have to program this in yourself manually. So let's take a look at a basic implementation of how you can get a character controller moving for your player. As you can see here in my demo scene, I've got a player object which has a character controller on it. Inside of this script, I've got 4 variables: a float for move speed, a float for gravity, a character controller private reference, and a vector 3 for our velocity. On start, we're just setting our controller and getting the component of character controller so that we can use this throughout our script. Then we're getting our player input. This will vary whether you're using the legacy or the new input system, which I will make a separate video accompanying this one, doing all of this with the new input system in comparison. Then using this input, we're calculating a move vector for the player. Then we're normalizing this move vector because if you're going diagonally, then you'll go faster, which we don't want. Then we access the .move function that is present inside of the character controller. We're using our move vector multiplied by our move speed multiplied by time.delta time to make it frame rate independent. Finally, to get gravity on our character controller, we're going to get the velocity.y plus equals gravity multiplied by time.delta time. Then we're going to move our character controller using this velocity. This will give us a constant downward movement, acting like we have gravity in physics. If I press play now, you'll see that we'll fall down to the ground, meaning that our gravity implementation worked, and I'm able to successfully move around pretty smoothly. So there's quite a few pros of using the character controller implementation. However, the physics-based stuff is a bit of a con if you want to have more physics-type interactions in your game. So with the character controller implementation done, let's move on to the rigid body implementation. But before we do, let's talk about some of the pros and cons of the rigid body version. So the pros are pretty self-explanatory. You get a lot of physics, collisions are pretty good, and it works well with other physics objects, so like it getting pushed, bumped off, knocked back, explosions. You can do all that stuff with it. However, the biggest problem with using the rigid body version is sometimes it can be a little bit unpredictable when your script gets larger and larger, and it can also introduce things like jittering or sliding along these lines, and you also have to use fixed update instead of update, which isn't major issue, but that is something you need to think about. And also there can be a performance overhead if you have a large environment and you just don't need this type of movement. So this time our player is going to have a rigid body and a capsule collider on them, as well as the script in which we're going to have the code in. So in our script we're going to have 3 variables, one for move speed, a rigid body reference, and a vector 3 for our movement input. On start, we're going to set RB is get component of rigid body. Then in our update, we're going to get our player's input like we did before, calculate a vector movement direction for the player, and then normalize this so that we don't get any diagonal speed increases. Then for actually moving the player around, we're going to do this inside a fixed update. And we do this because it's physics, and you should always do physics inside a fixed update. Inside a fixed update, we're going to do a new vector 3 called target position, and this is going to equal our rigid body's position plus our movement input multiplied by our move speed multiplied by time.fixed delta time. And then to round that off, we're going to do rb.move position by our target position. With this programmed in, if you now press play, you'll see that we'll drop down to the ground and we'll be able to move around kind of similar to how we were doing with the character controller. However, the big benefit with using the rigid body based movement means that you can now start applying forces and stuff to the character and do a whole load of funky shit that you want to do. Now for the last out of the 3, which we're going to cover today, is a vector-based movement system. Now really, this is the worst of the 3, but it's still good knowledge to have, and who knows, you might end up needing it someday. So in terms of the player setup, it's basically the exact same as the rigid body one. I've got a capsule, a rigid body, and then my script, which will handle the logic. Now if you don't want things like gravity, you can not have a rigid body for this one as well. You don't need it, but I'm putting it on here because I want gravity. Alright, now taking a look at the script, you'll see, like I said earlier, this is by far the simplest method in which we have out of the 3. So we only have one variable for this, and it's our move speed. We're getting our player input like normal, calculating a vector 3 move direction like normal, normalizing like normal, but this time we're going to get the transform.position, and that will plus equal move multiplied by move speed multiplied by time.delta time. So pretty much in this, we're essentially just manipulating its vector transform position. So you can run into a lot of issues with this one, but it's a nice one just to get up and running quickly. Okay, so I hope you found this video useful and it's helped you get any project that you're working on up and running quickly. So definitely have a play around with all three methods, see what you can do with them, because all of them have their own use cases, pros and negatives. But yeah, that's all for now. On this Friday, we're going to start looking at the new input system, and we're basically going to redo this, but with the new input system.